All right, welcome everyone to the next series of videos, and we'll be looking at correlation coefficient in the next set of videos. So here we're familiar with from ordinary level exams, GCSE exams, with our correlation coefficient, and today the approach has been to guesstimate the type or the nature of the correlation coefficient by doing what I would call an I metric. So we will look at the line, we will look at the general trend in the data points, and then determine whether or not the trend is upward or downward, or there's no linear trend discernible. And based upon that determination, we would say that the correlation was either positive if the trend was upward, as both x and y move together, um, or if the trend was downward, then we'd say that the correlation was negative, as x increased, y decreased, or as x decreased, y increased, or zero, where there's no discernible there's no discernible pattern in terms of functional relationship between the x's and the y's. So here we now segue into A level, where we're asked to move away from an imetric approach to a quantitative approach in terms of determining the nature of the relationship as well as the strength of the relationship. So in A level and under the previous dispensation, you would be asked to calculate the correlation, the sample correlation coefficient. You'd be given a sample of data for x and y, and you'd be asked to use a formula like this that would allow you now to generate the correlation coefficient and what's called the Pearson moment correlation coefficient. Now, if we understand it, the correlation coefficient comes out of an appreciation of the fact that what we're doing is we are normalizing the covariance between x and y. What that means is that we know that as we we can determine how x and y move together, how they co-vary, and when we determine that, when we quantify that, we generate something that is called a covariance. So the variance is how x moves against itself, or y moves against itself, and you're looking at a measure of the spread between x and the mean of x. And here the covariance is a measure of the spread between x and the mean of x multiplied by the spread between y and the mean of y. So if we normalize that, and by normalize what we mean is to reduce the measure from negative infinity to positive infinity, to now -1 to +1, and they have done that by dividing the covariance of x and y by the product of the standard deviation of x and the standard deviation of y. Of course, we don't really need to understand that, but it does help to have a sense of where these things are coming from, these tools that we're using. So we appreciate that the sample correlation coefficient is an estimation of the population correlation coefficient, which is the normalization of the covariance of x and y. And if indeed you're looking to move into a career to do uni courses that are quantitative, these are things that you will treat with as you progress. Now, as it relates to A level, what will you need to know? You will need to know how to use a calculator in order to do this. So no longer will we use this formula. We're expecting the calculator to do this. Additionally, we're now going to discriminate as to whether or not the number that we return is statistically different from zero, i.e., is the correlation really positive, negative, or is it as simple as zero? All right, and we're going to use a table of results in order to be able to perform the hypothesis test, and that will be for some exam boards, it will be the critical values for the correlation coefficient, and we'll walk through how to use that table in order to determine whether or not the sample correlation coefficient is actually statistically significant. And what that phrase statistically significant means is whether or not the value that we return is actually different from 0. All right, so stick around. We're going to look at a number of examples as it relates to estimating, calculating the correlation, the sample correlation coefficient, and then performing hypothesis tests on the calculated values.